2-6 is ratios and proportions. And you'll remember last year we had a chapter on ratios and proportions. This will be a section that reviews bits and pieces of all of that chapter. That's why there are 20 slides, you'll notice, but not to worry, it goes pretty quickly because lots of it you've had before. So we're going to talk about comparing, oh, what is that done? We're going to talk about comparing ratios and solving proportions, both of which I think worked pretty well for you guys. So let's see how this goes. Remember, ratios allow you to compare something. In this example here, we're going to be comparing the number of restaurants per 10,000 people in the U.S. as well as other countries. Okay, so you'll notice in the U.S., per 10,000 people, there are 0.43 restaurants, right? In Australia, there's 0.349. In Singapore, 0.273. So we can compare something in a like way by using ratios. Vocabulary, we're going to go ahead and write this list down. Don't write means, don't write extremes. We're not going to cover either one of those words. We're going to let those words go. So ratio, proportion, rate, unit rate, scale, and scale model. Those definitions will come up later. All right, here's the first one. A ratio is a comparison of two numbers by division. But yeah, you guys already knew that, right? We've done this one a million times, I swear. And in the case of the example we just had, the comparison was between the number of restaurants and the number of people. So we were comparing restaurants, right, compared to people and comparing them by division. Usually we look at it this way, although you can see ratios written in these other two ways as well. We'll be working with X over Y format. All right, one thing you know about ratios is that we can have equivalent ratios. If we know that there are 3.49 restaurants per 10,000 people, we could figure out how many restaurants there would be per 100,000 people by simply multiplying both the top and the bottom by 10, right? We'd get an equivalent ratio, and we could therefore find out how many 100,000. If we wanted to find out how many restaurants per million people, again, multiply by 10, and we'd get 34.9 restaurants per million people. Two equivalent ratios, right, are called a proportion. There's in your another vocabulary word, proportion. Two ratios that are equivalent. All right, let's determine whether two fractions or two ratios are equivalent. You can do that by putting them both in simplest form. So here we're comparing 2/3 to 16 over 24. 2/3 is already in simplest form. If I put 16 over 24 into simplest form by dividing by 8 on the top and the bottom, I get 2/3. So in simplest form, they are the same. That means these two ratios are equivalent. You can use this method, but more often than not, we're going to use the next method, which is called cross products. Everybody remember cross products, maybe? But we can use cross products to determine if two ratios are a proportion. If we have A over B, and it's equal to C over D, you may or may not remember that A times D is the same as B times C. That this times this is equal to this times this. Let's do an example. Let's say we have 4, 6, and 12/18. Okay, so the question is, are these two ratios a proportion? Well, is 4 times 18 equivalent or equal to 6 times 12? 6 times 12 is 72. 4 times 18 is also 72. So we can say, yes, they are a proportion. We also could have simplified them. True. Could have divided both of them and gotten both of these into their simplest form. But when we get more complicated problems, the cross products is going to be easier way to go. We'll look at a couple of more examples here and you'll see why. Okay, here let's determine if 2 over 3.5 is equal to 8 over 14. Is this a proportion? So we'd multiply 2 times 14. Is that equal to 8 times 3.5? Does it matter if I say 3.5 times 8 or 8 times 3.5? No, remember, multiplication is commutative, so it doesn't matter. All right, if I multiply 2 times 14, I get 28. Is that equal to 8 times 3.5? 8 times 3.5 is also 28. So yes, this is a proportion. All right, let's try another one. 0.3 over 1.5, is that equivalent to 0.5 over 2? Well, is 0.3 this times this equal to 1.5 this times that? So 0.3 times 2 is 0.6. And 1.5 times 0.5 is 0.75. Are they equivalent? No, not a proportion. Here are a couple practice problems for you. Pause your video, try these two problems, and I'll see you in a sec. All right. Solving proportions. To solve a proportion means to find the variable that's inserted in two ratios set up as a proportion. So for instance, here we have x over 10 equals 3 over 5. To solve for x means to solve a proportion. So we will use the same method. We're going to use cross products. And we'll go x times 5 is 5x, right? And 10 times 3. So 5x equals 30. And to solve for x, I'm going to divide both sides by 5. And in fact, I see that x equals 6. So to make this proportion true, x must be 6. Okay, let's try a little more complicated one. I mean, that one you could almost done in your head, right, Cameron? Yeah, I thought you already had it done in your head, right? Edward? Yep, all of you guys would like to do it in your head. But sometimes it gets a little more complicated, and you want to know how to set the problem up when it's a little bit more complicated. So here we have a little more complicated problem. We're going to do cross products to solve for x. So we have 7 times the whole phrase, x minus 2. We're going to have to distribute that. And then we'll multiply 14 times 2. Well, 14 times 2 we know is 28. And 7 times x minus 2 is 7x minus 7 times 2 is a negative 14. All right, then we will solve for x plus 14 on both sides. And we see that 7x equals 42. Divide by 7, and we find out that x equals 6. And you could check your work. You could set up 6 minus 2, substituting in the 6 for the x, over 14 is at equal to 2 over 7. This would be checking our work. Well, 6 minus 2 is 4 over 14. Is that proportional to 2 over 7? Yes. Here's some guided practice. 2 problems for you guys. Again, pause the video. Good luck. All right. Here's another definition. The ratio of 2 measurements having different units of measure is called a rate. And this is the key to the difference between ratio and rate. And the difference is one has units of measure. All right? So here's an example, $9.99 for 10 songs. All right? Different units of measure. Here we're measuring songs in dollars. All right? A unit rate, in a unit rate, the item is being compared to one of the items. So for instance, if we said that we wanted to find out what the unit rate of that is, it would be how much does one song cost, right? Well, I divide by 10, and one song would cost $9 or 99 cents, 99 hundredths to be exact. Okay? So unit rate has a denominator of 1. Let's try a real-world problem. In the past 2 years, a retailer has opened 232 stores. If the rate of growth remains constant, how many stores will the retailer have open in the next 3 years? So what do we know? So that's what we want to check first. What do we understand? We know that in 2 years, he opened 232 stores. We have to find out how many stores he will have open in 3 years. So what we're going to do, so our plan is we're going to set that up as a proportion. So we know 2 years relates to 232 stores. And we don't know how many stores relates to, excuse me, I wrote that backwards. And in 3 years, we don't know how many stores that will be. That's what we're going to find out. So that's our x. So we'll set it up as a proportion. Why not? Proportions are great for solving so many different kinds of problems. So there are 232 stores in 2 years. How many stores will there be? Oops, I just did that wrong again. How many stores will there be in 3 years? So this is stores on top and years on the bottom, right, guys? All right? So always keep the same unit of measure, whether it's stores or years, on either the numerator or the denominator. So to solve it, right, we'll just cross multiply. 232 times 3 equals 2 times x. 232 times 3 is 696 equals 2x. Divide that both by 2, right? And we get 348 equals x. So what does the x tell us? What does this tell us? This tells us that in 3 years, so I'd write a sentence now, in 3 years, there will be 348 stores. Okay? Then the last thing you want to do is check. Now you can plug that number back in and make sure it works, but at the very least, when you check your work, ask yourself the question, does that make sense? Does it make sense there would be 348 stores in 3 years? If there were 232 stores, it's a reasonable number. That could make sense. All right, there's your problem. Go for it. See you in a second. Okay, a rate called a scale is used to make a scale model of something that's too large or too small to be a convenient size, to be the actual size. And you'll remember we did scale, right? When we did our buildings, we used a scale like 1 inch equals 50 feet of the real building, right? So scale always had to do with something like, you know, the model over the real thing. So say it might be, the model might be 4 inches and the real thing might have been 200 feet. And in this case, 1 inch equaled 50 feet. Remember that, guys? Or it could be the reverse, where this had to get blown up. All right, so scale and scale model. Scale is a ratio that just talks about making a model. It's the proportion you use, the ratio you use to make a model. Okay, the Ramsey Cascade Trail is about 1 1/8 inches long on a map. With the scale of the map is 3 inches equals 10 feet. What is the actual length of the trail? Well, let's set this up. Let L represent the length. Well, we know that 3 inches is equal to 10 miles, right? So we have the scale and the map. Excuse me. The scale and the real thing, or the map in this case, right? Okay. Now we know on the map it's 1.5 inches long. So where's that going to go? We're talking about the map, so that's going to go up top, 1 1/8 inches, and we want to know how long that is for real. That's what we don't know, so that's our x. So now we're going to solve for x to find out the actual length on the trail of the Ramsey Cascades Trail. All right, so it'll be cross multiplying. 3 times x equals 10 times 1 1/8. All right. Or some of you already have your calculator out, probably changing that into a decimal. But I'm going to try it as a fraction. So we're going to multiply, I'm going to think of it as a 1 plus 1/8, okay? I'm going to multiply 10 times 1, which is 10, plus 10 times 1/8. Okay? So 10 times 1/8 is 10/8. And then, okay, so then we have to change this, the 10 to eighths, so we can add them together. So 10 over 1 is the same as 80 over 8 plus 10 over 8, right? Oops, that's an 8, not a 9. So that's what 3x is. 80 plus 10 equals, let's extend our page here. 80 plus 10 is 90 eighths equals 3x. So now we're going to divide by 3. Divide by 3, right? Those cancel out. We find that x equals, how do you divide fractions? Multiply by the reciprocal. Cancels, cancels, 1 and 30. We find out that x equals 30 over 8, right? Which simplifies to, oh, help me out here, 4, 3, how about 3? 3 and 6/8 or 3 3/4 miles, right guys? Miles, because it belongs right here. So it's how many miles it is. 3 3/4 miles is the actual length of the trail, and that would be your sentence. Okay, here's yours. Whoops, did I miss one? Let me see if there's any more slides. These might both be blanks. Oh, look at that. Isn't that sweet? Surprise. Shall we write surprise the end? Okay, that's it. See you next class.